Welcome to the Matter Station, where you matter. Coming to you live from Springfield, Illinois. What's that? I think we have a special news report. Special news report! Let's go live to Nancy outside for the details.
That's right, Darcy. This is a special news report because we finally found the linear equation. Oh no, where's Lenny at? The corporate's gonna kill us. Lenny! Wait, there she is! Did she really just fall? I'm sorry, Lenny. I'm sorry. Okay, where are you, Lenny?
I like to go on adventures.
Well, that makes sense. Well, what took you to go on this adventure? I like the adrenaline rush and not knowing where you're going. Okay. Well, I'm sure that Artemis missed you. Yeah, well, I go on adventures a lot, so I think he's pretty much used to it, but I'm sure he missed me. I'm sure he did too. So, yeah, I'm sure he missed you.
I don't like the touch.
I'm sorry, Lenny. So, how did you go on your trip? Don't they have a segment for this? She's so unprofessional. Yes, they do. I'm sorry. So, thank you, Lenny. Back to you, Darcy.
Can I get water? Don't touch me either. Who is this?
I'm sorry, Lenny.
Thanks, Nancy, for that special news report. Wow, linear equation sure went on a hectic adventure. Let's look at all the places that she stopped at. Starting in Springfield, Illinois, where Matter broadcasts from, down to Nashville, Tennessee, over to Lexington, Kentucky, up to Columbus, Ohio, the capital of Ohio, down to Cincinnati, over to Indianapolis, the capital of Indiana, up to Chicago, Illinois, the Windy City, over to Kirksville, Missouri, down to Jefferson City, the capital of Missouri, over to St. Louis, Illinois, and all the way down to Huntsville, her last stop, before making her way back to Springfield, Illinois, where we just broadcast live from.
This is our algebra timeline by Ashley, Carson, and Colleen. Rate of change. A ratio that describes on average how much one quantity changes with respect to change in another quantity.
3 ways to define slope. The first way is percent of change in y over x. The second way is to diverge from the vertical or horizontal incline. The third way is to change in y over change in x. M is the variable used for slope. Slope is referring to the incline of a line. Rate is how fast a line inclines or declines. St. Louis population. The greatest difference was in 1860 and 1870 because it is a difference of 161,000. The least difference was 1870 and 1880 because it was just 1,000 population difference.
Slope and direct variation represents proportional when k goes up, so does y. Equation y equals kx. The slope is the constant of variation, k is the variable. Here are some direct variation equation examples.
Direct variation. All direct variation graphs pass through the origin. The slope is positive if k is greater than 0. The slope is negative if k is less than 0. Slope-intercept form. Y equals mx plus b. M equals slope and b equals y-intercept. Example. Slope-intercept form. Write an equation in slope-intercept form when you know the one point on the line and the given slope. You don't know y, so you have y equals, you don't know. You know m, or the slope, so you have y equals, you don't know, the slope number, and then you fill in the slope number. You don't know x or k, so you have y equals something k plus. You know b, the y-intercept, so you have y equals mk plus b.
Slope-intercept form. To write an equation in slope-intercept form, when you know 2 points on the line, you first find the slope. Then choose one of the 2 points to use. Substitute the values of m, x, and y into the slope-intercept form and solve for b. Substitute the value of m and let x and y be x sub 1 and y sub 1. Write slope-intercept form using the values of m and b. How to find the slope-intercept form of a line when you know both intercepts. You find the slope by y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and substitute your y's and x's. Then you use slope-intercept form and subtract m, or slope, with your answer, y minus mx plus b. Solve for b. Point slope form. Equation is y minus y sub 1 equals m times x minus x sub 1. Y sub 1 and x sub 1 are the variables that represent a given point. M equals the slope. Example, describe how you could graph 1, negative 4 and have a slope of negative 5. Using what you know about point slope form, you plot a point at 0, 0 and at 1, 4. Go down by negative 5. Connect them together with a line drawn by a ruler. Changing point slope form equation into standard form. First you do distributive property with m and x and m sub 1 and x sub 1. Then you move y sub 1 to both sides by adding y sub 1 to negative y sub 1 and to mx minus mx sub 1. Then you move the x term to the other side by adding its opposite, and make sure that it is in the correct order, ax plus by equals c. Writing a point slope form equation in slope-intercept form. You solve for y, distribute what is in parentheses, and get it to where the problem is, y equals mx plus b. Parallel lines. 2 lines that go on forever at the same slope rate and never touch are parallel lines. Parallel lines always have the same slope. Writing equations of lines when you know a point on the line and the equation of a given line. Write the point slope form using the point on the line and the slope of the given line. Perpendicular lines. Perpendicular lines are 2 lines that intersect and form a T in 90-degree angles. The slope of perpendicular lines are negative reciprocals. Their slopes are always opposite. Writing equations of lines perpendicular to a given line is you know a point on the line and the equation of the given line. Write the point slope form using the point you know on the line and the negative reciprocal of the given point. Slope-intercept form. An equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. Point slope form. Y minus y sub 1 equals m times x minus x sub 1, where m equals slope.